So over here, problem 1 says to combine like terms in the following equations and to solve. And so we have some terms over here on the left side to combine, but there's only one constant term on the right side, so there's nothing to combine on the right side just yet. And so first we're going to combine all of the variables on the left side. And so we're going to combine this 3x with this 5x over here, which is going to give us 8x. And the plus 12 over here is just going to stay there. So that's going to give us 8x plus 12 is equal to 108. Next, we want to isolate this variable term on its own. And so we're going to use inverse operations to get this 12 over to the 108 over here. So we're going to subtract 12 from the left side, and we're also going to subtract 12 from the right side, because whatever you do to the left side is also needing to be done on the right side. And so 8x plus 12 minus 12 would be equal to just 8x, because the 12s cancel themselves out. And so 8x is equal to, then over here on the right side, 108 minus 12 would be equal to 96. And so now what we're going to want to do is we want to divide the equation by 8, so we have x alone so we can solve the equation. So we're going to divide both sides by 8 right here. And so 8x over 8, the 8's cancel themselves out and leave us with just x, which is equal to 96 divided by 8, which is 12. And so that is our answer for this first equation over here. Moving on to the next equation over here, we want to combine the like terms and solve. And so in this one, on both sides, we don't really have anything to combine, because on both sides there is only one variable term and one constant term. And so what we're going to do is we're going to go straight to getting all of the variable terms on one side and getting all of the constant terms on the other side. And so first we're going to get the variable terms on one side, and I'm going to get this negative 3a over to the left by the 12a. And so we're going to be using the inverse operations. And so since this is a negative 3a, we're going to add 3a on this side of the equation and to this side of the equation. And we're going to add them together. And so 12a plus 3a gives us 15a plus the 14 on the side over there, plus 14, which is equal to minus 3a plus 3a. They both cancel each other out, and that's just going to leave us with 74 right there. And so next what we want to get this constant term over here to the right by the 74. And so using inverse operations, I subtract 14 from the left side and 14 from the right side. And that leaves me with 15a plus 14 minus 14. Those two cancel each other out, which leaves me with 15a is equal to 74 minus 14, which is 60. Now our last step over here is we want to get a alone to be able to fully solve this. And so to get a alone, we're going to have to divide the side by 15. And so we're also going to divide the other side by 15. And so 15a over 15, the 15's cancel themselves out, leaves us with a, which is equal to 60 divided by 15, which is 4. And so that is our answer for this one right here. And so on this next one over here, we have to combine the like terms, and on the right side, we can't combine any like terms, but on the left side we can. So we want to combine the 6y and the 2y with each other. And so we're going to add 6y plus 2y is equal to 8y, and we have that negative 24 right there, leaving us right there. And on the other side, we have 96 plus 3y. Now we want to isolate the y term on one side, and so we're going to use the inverse operations and subtract 3y from both sides. And so 8y minus 3y gives us 5y minus the 24 we already had, which is equal to 96 and then 3y minus 3y cancels each other's out. So it just leaves us over here with 96. And so now what we're going to want to do to isolate it, we're going to use the inverse operations again and just add 24 to each side to get rid of the 24 on the left side and leave the 5y alone. And so 5y and then the minus 24 plus 24 just cancels each other's out, so it leaves us with just 5y, which is equal to 96 plus 24, which gives us 120. And so to get the y completely alone and to solve this completely, we're going to divide both sides by 5. And so 5y divided by 5 leaves us with just y, which is equal to 120 divided by 5, which is 24. And so that is our answer on this one. Let's move on to the next problem. Problem number 2 says distribute the following equations and solve. And so what we're going to want to do over here is on this first one, we have the 6 that we can distribute to the terms inside of the parentheses. And so we're going to do just that, and we're going to distribute the 6 to the 4w and to the 5. And so 6 times 4w gives us 24w, and then the 6 multiplied by 5 gives us just 30 plus 30, which is going to be equal to the 174 we have over here. Now that we have that, we want to get the w term, the variable term, alone on one side. And so to get rid of the 30, we're going to subtract this side by 30, and then subtract the other side by 30. And so that's going to give us 24w, and then the 30s cancel each other out, which is going to leave us with 24w is equal to 174 minus 30, which is going to give us 144. And so it says 24w is equal to 144. And to solve for the w right here, we're going to divide this by 24 and divide the other side by 24. And so 24w divided by 24 leaves us with just w, which is equal to 144 over 24, which is equal to 6. And so that is our answer for this one. For our next one, we have to distribute on both sides. And so let's start with the first side on the left. We're going to multiply the 2 with the 10x and the 2 with the 52. And so 2 times 10x is equal to 20x, and then 2 times 52 is equal to 104. So this left side gives us 20x plus 104 is equal to, and now on the other side we want to distribute the 16 to the x and to the negative 3. And so 16 times x is equal to 16x, and then 16 times negative 3 is equal to negative 48, so minus 48. And so that's our equation right here, and we want to get the variable term, which in this case is x, over on one side. So I'm going to move this 16x over to the right with the 20x. And so to do this, I'm going to subtract 16x on this side, and then subtract 16x on this side. And so this is going to give us 20x minus 16x leaves us with 4x, and the plus 104 that we previously had, which is equal to the 16s both cancel each other out, and so it's going to leave us with negative 48. Now we want to get rid of this 104 to just leave this x term alone on that side. And so to do this, we're going to subtract by 104 on this side and subtract by 104 on the other side. And so 4x is right here, and then 104 minus 104 leaves us, they cancel each other out, and so that just leaves us with 4x. And then the negative 48 minus 104 gives us negative 152. And so now what we're going to do is we're going to want to solve for just the x, and so we're going to divide these terms by 4 since it's a 4x, and the 4's cancel each other out and leaves us with x, which is equal to negative 152 over 4, which is negative 38. And that is our answer for this one. So this next one over here, it looks a little bit weird because on the left side it has a 6 dividing this whole top term over here. And so what we're going to want to do to solve this and make it easier on us is just to get rid of this 6 right here that's dividing the top terms. And so to do that, what we're going to do is we're going to multiply both sides by 6. So we're going to multiply this side by 6, and we're going to multiply this side by 6. And so multiplying this side, the left side, by 6, it's going to cancel out the 6 that's dividing it, and it's just going to leave us with this top term over here, which is going to be equal to negative 7 times negative z plus 3 is equal to 35 times 6, which is 210. And so that's our equation over here, and if you see, we need to distribute this equation on the left side. We want to multiply the negative 7 by the negative z, and we want to multiply the negative 7 by the 3. And so we're going to distribute this, and so negative 7 times negative z is going to give us positive 7z, and then negative 7 times negative 3 is going to give us negative 21, so that's minus 21, which is going to be equal to 210. Now to isolate this, we want to get rid of the 21 over here to have the z variable term isolated on the left side. So we're going to add 21 over here, and we're going to add 21 to the other side. So that's going to give us 7z, and then the negative 21 and the positive 21 cancel each other out, which is just 7z, is equal to 210 plus 21, which is equal to 231. And then now to completely solve this, we're going to divide this by 7 to get rid of the 7z and just solve for the regular z. So we're going to divide this side and this side by 7. And so 7z divided by 7 leaves us just z right here, which is equal to 231 divided by 7, which is 33. And that is going to be our answer on this one. Let's move on to the next problem. Problem number 3 says to solve the following equations. And so let's look at the first one over here. This one is also a little weird because all of the m terms on the left side have fractions underneath them. So they have 2, 8, and 4. And so we want to get rid of all of these fractions. And so what we're going to want to do is multiply this entire side of the equation by a term that can get rid of all of the denominators on the fraction here. And so if we multiply all of the terms in this on the left side of this equation by 8, it will cancel out everything on the bottoms, and it will leave us with an equation with no fractions. And so we're going to multiply this side by 8, and we're going to multiply this side by 8. And so if you can look on the left here, this sort of looks like the distributive property. And so that's exactly what it is, and we're going to use the 8 and we're going to distribute it to the m over 2, to the 5m over 8, and to the m over 4. And so 8 times n divided by 2 is going to leave us with just 4m for this first one over here. And then we have the 8 times 5m gives us 40m, and then we divide that by the 8 over here, which is going to leave us 5m. Next we multiply the 8 by negative m, which gives us negative 8m, and we divide it by the 4 over here, which gives us negative 2m, which is all going to be equal to 56 because we multiplied the 7 by the 8. So That's going to be 56. Now that we have this, you can see there's quite a lot of like terms on this side. There are three variable terms on this side, and so we're going to want to combine them all. And so 4m plus 5m is equal to 9m. And then you subtract 2m, which would give us 7m as a total. And so 7m is going to be equal to 56 on this side right here. Now we're going to divide this side by 7 and this side by 7 to get the m alone. And so 7m divided by 7 leaves us with m, which is equal to 56 divided by 7, which is 8. So m is equal to 8. Moving on to the next equation, we have this one over here, and you can see it's the distributive property, but instead of being a whole number that's being distributed to the d minus 6, there is a fraction that is being distributed to the 3 minus 6. And fractions are sort of hard to work with, so I'm going to try it, and I'm going to get rid of this fraction over here. And so to do that, I'm going to multiply this side right here by 2, and I'm going to multiply this other side right here also by 2. And so since this 3 over 2 is being multiplied by something inside parentheses, it's considered just one term. And so when I multiply this by 2, it'll only get rid of the 2 denominator in the fraction right here. So these two 2's will cancel out and leave us with 3 times d minus 6, which is going to be equal to 15 times 2 on the other side, which is 30. Now we're going to solve for this, but there are actually 2 ways we can do this right now and solve for it. And so I'm going to split this in half, and I'm going to show you the 2 ways. The first way we could do this is we could just straight up distribute this and then solve. So we could distribute the 3 times to the d and the 3 to the negative 6, which would give us 3d, 3 times d is 3d, and then 3 times negative 6 is minus 18, which would be equal to 30. And then we would get the 3d on its own over here, so we're going to add 18 over here and add 18 over here. And so that gives us 3d, and the 18's cancel out, so that's just 3d is equal to 30 plus 18, which is going to be equal to 48. And then to get just the d and solve this completely, we're going to divide this by 3 and then divide the other side by 3, which is going to give us d is equal to 48 divided by 3, which is 16. And so that would be our answer. Now the other way to do this, we're going to do it and we should get the exact same answer. And so the way we're going to do this one is that instead of distributing this, since we have 3 times the d plus 6 in parentheses, which is equal to 30, what we could do instead of distributing is divide this side, the left side, by 3 and then divide the 30 by 3. Right, and so since what we're distributing to the parentheses inside is divisible to the constant term that is on the other side, we could just divide it by 3. And so that's what I'm going to do on this one. I'm going to take the 3 times d minus 6, which is equal to 30, and I'm just going to divide this side by 3. And then since I divide this side by 3, I divide the other side by 3. And so these 3's cancel out, and it just leaves us with the d minus 6, which is equal to 30 divided by 3, which would be 10. Now this is simpler, and we don't have to divide. And now all we have to do is add 6 over here and add 6 over here to get the d completely alone. And so we have d, and then minus 6 plus 6 is 0, and they cancel each other out. So it's just d is equal to 10 plus 6, which is 16. So that is our answer. And you can see that we got the exact same answer either way we did it. And so they're both right. Let's move on to our last one real quick and finish up. On this one over here, we have the g plus 7 on one side, and then on the right side, we have to distribute. And so let's just write the g plus 7 right here. So g plus 7 is equal to, and then we distribute the 11 to the 2g, and then the 11 to the negative 7. And so 11 times 2g is equal to 22g, and then the 11 times negative 7 is equal to minus 77. And so now that we have that, we want to get our g variable term isolated on one side. And so we're going to subtract g from this side and then subtract g from this side. And so we're going to get g minus g cancels each other out, leaving us with 7, which is equal to 22g minus g is equal to 21g minus 77. Now we want to get this one alone, and so we're going to come here and add 77 from this side, and we're going to move it onto the left side, so we're going to add 77 here too. And so 7 plus 77 is equal to 84, which is equal to 21g, and then these two cancels out, and it just leaves us with 21g. Our last step is going to be to get this g completely alone, and so we're going to divide this by 21, and then divide the other side by 21, and so 84 divided by 21 gives us 4, which is equal to 21g divided by 21 gives us just g. And so this says 4 is equal to g, or we can rewrite that as g is equal to 4. And that is our answer on this last one. I hope you guys understood everything I said in the video. Please like, subscribe, and share, and don't forget to comment any questions you had down below or any other topic ideas you would like me to cover in the future. Thanks for watching. Bye!